looking at redox half equations. These would be reduction and oxidation reactions. And a redox half equation does exactly what it says. It tells you half the story, either the reduction component or the oxidation component. We need to balance these half equations. And I strongly suggest, if you haven't done so, view the video on oxidation numbers before this one. We'll be relying on those. Identifying redox reactions. Redox. Reactions involving reduction and oxidation. That's where the term redox comes from. It's a combination of the two. Oxidation is the loss of electrons. Reduction is the gain of electrons. And reduction and oxidation cannot happen independently. They have to happen together. That's why we coined the phrase or the term redox. If one species is oxidized, then another must be reduced. The oxidized species acts as the reducing agent. The reduced species acts as the oxidizing agent. We could work out the oxidation number of every element as a reactant or product. If the oxidation number goes down, it's been reduced. Clearly, going down is reduced. If the number goes up, it's oxidized. So, identifying the oxidized and reduced species, the oxidizing agent and the reducing agent. In my first example, Mg plus 2HCl gives me MgCl2 plus H2. Magnesium starts with oxidation number 0. It's an element. It's not combined with anything. Electrons have neither been lost or gained. But it ends up with plus 2. Why plus 2? Two reasons. Mg is in group 2, so forms the ion Mg plus 2, and it's combined with 2 negatively charged chloride ions. So Mg has gone from Mg0 to Mg plus 2. It's oxidized. If it's oxidized, it's the reducing agent. Hydrogen starts with plus 1. We're familiar with hydrogen forming that H plus ion, and it ends as 0 as an element, H2. It's been reduced. Plus 1 going down to 0 is reduction. HCl is the oxidizing agent. And notice I'm saying HCl, not just the hydrogen. Any reaction involving an element as reactant or product is redox. Example 2. If I look at that equation, I see chlorine has been formed as an element. It's redox. That's all I need to see. An element is there. It's a redox reaction. Okay, chloride, the ion, started with oxidation number -1 and ends as the element chlorine, oxidation number 0. It's oxidized. Now, HCl is now the reducing agent. Mn starts with oxidation number +4. Combined with 2 oxygen atoms, O we'll always assume is -2 unless it's a very unusual situation. So Mn starts +4 and it ends up +2 combined with just 2 singly negatively charged chloride anions. It's reduced. MnO2 is the oxidizing agent. Example 3. No elements involved. My easy way out is gone. But I know O is -2 everywhere. I know that H is +1 everywhere. Mg starts off as +2, ends up as +2, no change. Cl, -1 with the hydrogen in HCl, H being +1, -1 in MgCl2 because it's Cl-. No change. H, of course, is +1 on both sides. O is -2 on both sides. it's not redox. Next example. Cl2 is involved as an element, it's redox. Some Cl starts with oxidation number 0, that's in the element, and becomes -1, combined with Fe. The number's gone down, it's reduced. Means that chlorine is the oxidizing agent. Fe starts with oxidation number +2, combined with 2 Cl- anions, and it ends with +3. It's been oxidized. FeCl2 is the reducing agent. Now, a more complicated looking one, but not if you think about it. H2 I'm always going to assume is +1, so +1 on both sides. Oxygen, a lot of oxygen about, always -2. I'm only going to look at the S and the N. In H2SO3, sulfur starts off with oxidation number +4. -6 for the 3 oxygens, partly cancelled out by +2 for the hydrogens, making sulfur +4. It ends up as +6, so it's oxidized. H2SO3 is the reducing agent. Nitrogen starts off with oxidation number +4, combined with 2 oxygens. Ends with +2, it's gone down, it's reduced. NO2 is the oxidizing agent. Half equations separate oxidation and reduction, showing the loss or gain of electrons. They either show a reduction or oxidation process. During oxidation, electrons are lost, so electrons appear on the right-hand side of the equation. I must have plus a number of electrons, never minus. During reduction, electrons are gained, so electrons appear on the left-hand side of the equation. And when constructing half equations, following points must be remembered. Only one element in the half equation changes oxidation state. The half equation must balance for atoms. The half equation must balance for charge. So when we're balancing half equations, balance the atoms of the oxidized or reduced atom. If there's an excess of oxygen on one side of the equation, then the appropriate number of water molecules must be added on the other side. I'll look at my example below. VO3- going to V plus 3. I've got 3 oxygens on the left-hand side already. I need 3 waters on the right to balance. Okay. So once we've done that, this will then produce some excess hydrogen atoms. These should be balanced by putting the appropriate number of hydrogen ions on the other side of the equation. Back to my first example. I've already added 3H2O on the right. I need to add 6H plus on the left. Point 3. Add the appropriate number of electrons to balance the charges on each side. So, in my example, VO3-, that's 1 negative, plus 6H plus, 5 plus altogether, going to V plus 2, the only thing with charged on the right. My overall charge is down by 3. Plus 5 overall in the reactants, plus 2 in the products. I need to add 3 electrons to the reactants. Done. Now, in parenthesis above number 3, I'm saying you can check that you added the correct number of electrons by working out the oxidation numbers before and after. Well, in VO3-, V starts off as plus 5. In the products, it's V plus 2. That's clearly reduction. It's gone down by 3, and 3 electrons were added to the reactants. It works. 2 more examples. The half equation for the conversion of SO3-2 to SO4-2. Adding my H2O and H plus as required takes me here. Now, my total charge on the left has gone from -2 to 0 overall on the right. 2 electrons needed to be added to the right-hand side to make the charge on both sides -2. Done by here, and that's it completed. Make sure the atoms of every element balances. If there's extra oxygen or hydrogen on one side, counter it by using H2O and H+. Last example. The half equation for the conversion of Cr2O7-2 to Cr plus 3. Firstly, balance my atoms of Cr. I must have 2 Cr plus 3 on the right. Now, adding my water and H plus as required. First off, Cr2O7-2, I need to add 7 H2O to the right. From there, that's 14 hydrogens, I need to add 14 H plus to the left. Check the charge on each side. In the reactants, comes to plus 12 overall. In the products, comes to plus 6. I need to add 6 electrons to the reactants to make charge balance. And that is now complete. If you found that useful, please hit like, please hit subscribe to be informed about more content, because there will be a lot more content coming out. Thank you.